Okay, the third part of log is the property of log functions. So there are three properties: product rule, quotient rule, and power rule. So let's look at the product rule first. So the product rule means if you have log with some base b of a product m times m, so it's the product of two powers. Okay, so b is the base, and these are two powers. Product of powers, by this formula, you will get the sum of two logs with the same b, same base b, so power m and power n separately. Okay, so log of the product is sum of the log. Okay, is the sum of the log. So this is the product rule. Let's look at some examples. So let's say log 2, and then this is 3 times 5. Okay, so now we use the product rule. We will have the sum of two logs with the same base 2. Okay, so the important thing is we have the same base here. Same base number 2. Okay, yeah, and then we have log 2 of 3 plus log 2 of 5. So this is the product rule. We change a product 3 times 5 to the sum of two logs. These are two examples in my slides, in the slides. So we use the same product rule. So here base is 6, okay? And product of powers, 7 times 11. So by using the product rule, we got log 6 of 7 plus log 6 of 11. So the next example, there's no base here, so it's the common log. No base means base is 10. So if you want, you can add the base here. Okay, so the product is 100 times x, so we got log 10 of 100 plus log 10 of x. So here we can simplify log 10 of 100. So what is log 10 of 100? So it's number 2, right? Remember, we have the counterclockwise or clockwise direction. 10 to the second power is 100. So log 10 of 100 is 2. We got 2 plus log 10 of x is the answer after the product rule. The second rule is the quotient rule. Quotient of powers. Okay, so we have log with base b, and then there's the fraction or quotient m over n, or m divided by n. Okay, so if it's a multiplication, we have the sum. Now it's a division, m divided by n. So m over n is m divided by n. So quotient rule is we have still the same base b. It's a subtraction of two logs. So log b of m minus log b of n. Product is the sum, quotient is the difference. Okay, is the difference of two logs. Examples. Okay, examples. So let's still use log 2, right? 5 over 3. So this will be log same base 2 minus another log with the same base 2. Okay, so 5 is in the numerator, so the first one is 5. 3 is in the denominator, 3 is the second one. So it's log 2 of 5 minus log 2 of 3. So two more examples, okay, two more examples. So same base, okay, same base, number 8. So quotient, numerator 23, so the first one is 23. Denominator is x, so the second one is x. So it's log 8 of 23 minus log 8 of x. Natural log, so Ln means base e, okay, Ln means base e. So let's talk about this part only, okay. We change this quotient to ln e to the 5th power minus ln 11, okay. So ln e to the 5th, so let's add the base e here. So what is this number? Okay, what is this number? So we use the counterclockwise direction, so e to the question mark is e to the 5th, so question mark is equal to 5. Then we got this number 5. Okay, so the answer is 5 minus ln 11. The last rule is the power rule, okay, is the power rule. So we take log of a power m to the p's power here. Okay, so log b of a power m to the p's power. So what's the power rule? Okay, what's the power rule? We just move this exponent p to the front of the log notation. Okay, so we move p to the front, so we got this p, and then we got log with same base b of m. Okay, so this is the power rule. So for all these three rules, we always have the same base. So that's the key, same base. Let's look at this question. Log with base 6, and then 3 to the 9th power. Okay, you take a log of a power, 3 to the 9th power. So what's the power rule? We move the exponent number 9. So this exponent number 9 move to the front. So you will get 9, and then log with the same base 6 of 3. Okay, of 3. So you just move the exponent to the front. That's the power rule. Okay, that's the power rule. One more example about power rule. Okay, so this is a common log. What's the base? Base is 10. Okay, so we move this exponent number 2 to the front. So the answer will be 2, and then log with base 10, and then x plus 2. Okay, so now let's look at these three rules again. So if it's a product, we get a sum. If it's a quotient, we have a subtraction here. And then the power is move the exponent p to the front. Okay, so these are the three rules about log. Okay, so now let's look at another example. Log base b of x to the 4th power times cube root of y. Okay, so first we change cube root of y to the rational power. Log b x to the 4th times y to the 1/3. So now this multiplication, product means addition for two logs. So we have the same base b x to the 4th plus log b of y to the 1/3. So product is the sum. Now we have the power rule, right? Power rule. So these two exponents will go to the front of their log. So the answer will be 4 log b of x plus 1/3 log b of y. One more example. Log 5 of radical x over 25 y cubed. So first we change radical x to rational power. So this is log 5 x 1/2 power over 25 y cubed. And then this quotient, we use quotient rule. So this is log 5 x to the 1/2 minus log 5 25 y cubed. So for the first part, we move exponent 1/2 to the front. Then we got 1 over 2 log 5x minus, so now we have a product inside the second log. So 25 times y cubed, so this is the addition. Log 5 of 25 plus log 5 of y cubed. So for y cubed, this exponent is 3. Well, same power rule, go to the front. And for this, log 5 of 25 is number 2. So finally we got the answer. 1/2 log 5 x minus 2. And then minus 3 log 5 y. Okay, so this subtraction, there's a middle bracket, so the subtraction applies to both two logs inside the middle bracket. So sometimes we also use the backward of these three rules. So you are given a sum of two logs, and then we know is the product of mn. If you are given a subtraction, we know is the quotient m over n. So if you have a p in front of the log, you will put it on the shoulder of m to make a power m to the p's power. Okay, so it's the backward of the same rule. Okay, the same rule. Examples. Let's look at log 25 plus log 4. It's an addition of two logs. So first, you know the missing base is 10. Okay, and then we know the sum is the same base 10, and then we multiply these two powers. So it's 25 times 4. It's the product rule. Okay, backward of the product rule. So 25 times 4 is 100. So we got log 10 of 100, which is 2, because this is 10 squared. 100 is 10 squared, right? So the answer is number 2. Okay, so we have two bad numbers. Log 10 of 25 is a bad number. Log 10 of 4 is a bad number. But when you add them, you get log 10 of 100. You get integer answer number 2. More examples. Let's say is log 2 x plus 7 minus log 2 of x. Okay, so it's a subtraction. So we know quotient rule. So the first part, x plus 7, this is the numerator. So we got x7 on top. And then this is the denominator, x. So we combined two logs to one log form. So the answer is log 2 of x plus 7 over x. Okay, so one more example. If we have 2 log base 3 of x plus 1/2 log 3 of y. Okay, so how can we put them together to get a single log form? So first we have to put these back to the powers inside the log. So we got log 2 log 3 x squared plus log 3 y to the 1/2 power. Okay, it has to be the same base 3. Okay, same base is the key for all these three formulas. And then the sum implies a multiplication for the powers. So it's x squared times y to the 1/2 power. And some book also change the rational power to radicals. Okay, 2 radicals. Change base formulas. So this is actually for the calculators or computers. Okay, so calculators or computers, they only have common logs or natural logs. So what's common log? Base 10. Okay, what's natural log? Base e. Right? E is the special number between 2 and 3. Okay, so if you have a special number log 2 of 3, so how to calculate this in the calculator or computer? So we change log base 2 of 3 to 2 logs. Okay, if you use common log, you get log 10 of 3 over log 10 of 2. Okay, so it's a common log over a common log. So here the power will goes to the numerator for this new base. Okay, so this is the numerator, and the base 2 will be the denominator. Okay, yeah. So we change base 2 of log 3 to a ratio of 2 common logs, log 10 of 3 divided by log 10 of 2, and then you can use calculator. Okay, you can use calculator. So now let's look at these 2 examples together. So we are looking at this same log form. Okay, log with base 7 of 2506. So in the first solution, they change it to common log. Okay, so you got log 2506 over log 7. So this is the numerator, this is the denominator. So by using calculator, we got 4.02. That's the first example, first solution. So the second one, we use common log. We use base e. So log 7 of 2506 is ln 2506 over ln 7. So use calculator, you will get the same answer. Okay, the same answer. So it doesn't matter which base you pick. After you use calculator, you will get the same answer. You can use natural log or common log. 3.4, section 3.4 is exponential and logarithmic equations. We will solve some equations by using all the properties. So first, let's look at exponential equations, sorry. Okay, so what's this property? This property is if you have the same base, b, and if you have the same power, b to the mth power is equal to b to the nth power, then we have the same exponent. Then we got m has to be equal to n. Okay, so for example, if you have 5 to the x is equal to 25. So what is 25? 25 is 5 squared. So now we have the same base number 5, same base. So this equation implies it's an equation for the exponent, so x is 2. That's the property, okay? Same base implies same exponent. So next example is a little bit harder. 5 to the 3x minus 6 power is 125. We want to solve for x. Solve this equation, okay? So first you have to change this part to a power of 5. We need same base. Number 5. So 5 to the 3x minus 6 power is 5 cubed. 125 is 5 cubed. So same base, number 5. Now we have a new equation for the exponent. So 3x minus 6 is 3. So now you move 6, negative 6 to there. You got 3x is 3 plus 6. 3x is 9 divided by 3. X is 3. So this is the answer. Okay, this is the answer. So if you can change both sides of the equation to the same base, then you will get an equation for the exponents. Okay, so this is the equation for the exponents. Solve this linear equation, you got the answer. Okay, other example. So 8 to the x minus 2's power is 4x plus 3's power. So the problem is now we have different base. Base 8 and base 4, they're different. So our goal is you have to have the same base. So how can we change 4 and 8 to same base? We use base 2. So what is 8? 8 is 2 cubed. So this is number 8. Okay, and 4 is 2 squared. Then we have base 2. Okay, yeah. So now we need power of a power rule. So 2 to the 3 times x minus 2's power is 2 to the 2 times x plus 3's power. So now we have the same base number 2. So we get the equation of the exponent. It's a new linear equation without the powers. Okay, without powers. So we have 3x minus 6 is 2x plus 3. Okay, solve this linear equation, you will get x is 9. So I have a small mistake. So this is 2x plus 6. Right? So 2 times x, 2 times 3, 2x plus 6. And then we got the equation solution, x is 12. Okay, it's not number 9, sorry. So now let's talk about the second method to solve exponential equations. So let's look at this example. Again, 5 to the 3x minus 6 is equal to 125. Okay, so we can use log. We can change this to the log form, right? So this means log with base 5. So 3x minus 6, this exponent will be on the right hand side. And the 125 will be inside the log. So let's check it. 5 to the this 3x minus 6 power is 125. So after you change exponential equation to a log notation, then we can use definition of log to find log 5 of 125. So what's log 5 of 125? It's 3. So we got 3 is 3x minus 6. Okay, so you move 6. You got 3 plus 6, 9 is 3x. So we got x is 3. Okay, so we can use property of exponential equations to solve it, or we can use log to solve it. One more example. So the equation is 8x plus 2's power is 4x minus 3's power. So it's different base. Okay, it's different base. So now the new method, we will use log notation. We take log on both sides of the equation for the base 2. So in my first method, we use base 2. We change 8 to 2 cubed, 4 to 2 to the second power. So now we just use log. So log base 2 of this left hand side is equal to log with base 2 of the right hand side. We get a new equation of log, and then we use the power property. Powers rule, move this to the front, move this part to the front. Then we got x plus 2 times log 2 of 8 is x minus 3 times log 2 of 4. So x plus 2 times 3 is x minus 3 times 2. And then distribution rule again, 3x plus 6 is 2x minus 6. So move terms of this linear equation, we got x is negative 12. Okay, so method 1, we use properties of exponential equations. Exponents, same power means same base means same exponents. Method 2, we just use log. Either we use definition of log, that was the previous example, we use definition of log, or we take log on both sides of the equation. Okay, yeah, with same base. Okay, with same base. Okay, so one more example. 10 to the x power is 8,000. Okay, so we take log on both sides. It's the common log, so we don't need to write on the base 10. Okay, so log 8,000. So this is the power rule on the left. We move x to the front, then we got x log 10 is log 8,000. So what's log 10? Log 10 is number 1, so we got x on the left. Right hand side, you use calculator. Okay, so calculator give us the number 3.9. Okay, so we get the answer, x is almost 3.9. A new example. 3 to the 2x minus 1's power is 7 to the x plus 1's power. So the problem for this question is 3 and 7 are different base and we cannot change it to the same base. Okay, so you cannot change this to base 2 or base 3 or base 5. So we have to take log on both sides of the equation. Okay, in this solution they use base e. Okay, they use base e. So I'm going to follow that. Let's take log with base e on the left and the right side. And then we use the power property. Move this to the front. Move this to the front. So we got 2x minus 1 times log 3 is x plus 1 times log 7. Okay, so now distribution, solve this linear equation. 2x times log 3 minus log 3 is x times log 7 plus log 7. Move x terms together, so we got x 2 log 3 minus log 7 is log 3 plus log 7. And then divide by this multiplier. We got the answer x. Okay, so log 3 and log 7, they are just some decimal numbers. You use calculator, you can simplify this part. You got x is 12.11. Okay, so you can either keep this expression as the answer or use calculator to get a decimal answer. Now let's talk about the logarithmic equations. So you're given a log form. Okay, this is given. And then we use definition of log, change it to exponential form. And then solve this exponential equation. Or maybe linear or maybe quadratic equations. Okay? Yeah. So definition of log is very important for this part. Our first example, log 2 of x minus 4 is 3. So what's the definition of log? It's either counterclockwise or clockwise, right? So we change log notation to exponential form. So 2 to the third power is x minus 4. So what's 2 to the third power? 8. So 8 is x minus 4. Plus 4 plus 4, we got 12 is works. Okay, so step 1 is the crucial step. We use definition of log. So another important thing for log equation, after you get a solution, you have to check it. You have to check the solution. Okay, because there's a condition. So if you look at log base b of some m, what's our condition for this m? We need m is non-negative. It's positive. Sorry, it's positive. Okay, it has to be positive. So you have to check your solution. Okay, so when you plug in the answer 12 to check it, so log 2 of 12 minus 4, so which is log 2 of 8, so this is 3. So it is a solution. Okay, it is a solution. So check your solution after you solve it for log equations. For all log equations, you check the solution. Next example. Log x plus log x minus 3 is 1. So we have two log forms in the left hand side. So first step, we put them together by using the product rule. Okay, sum of the log is the product of powers. So x times x minus 3 inside the common log. And then we use definition of log. Okay, we put base 10 here, so 10 to the first power will be this product. Okay, so 10 to the first power is x times x minus 3. And then we got a quadratic equation, right? 10 is x squared minus 3x, move 10 and then solve it. You got two solutions, x is 5 or x is -2. Okay, so the details for the quadratic equation is here. You can look at that, you can check that in my slides, in my lecture PPT file. So after you got these two numbers, you have to check it. Okay, check solutions. Okay, check solutions. How to check solutions? You plug in. Okay, you plug in. So when you plug in 5, that's okay, right? If x is 5, what do you got? You got log 5 plus log 5 minus 2. So everything is positive. So this is 5, this is 3. Sorry, x5 minus 3. Okay, 3. So solution number 5 is okay. But when you plug in this -2, there is a problem. Okay, so let's plug in -2. So if x is -2, what do we got? We got log -2 plus log -2 minus 3. So we got log -2 and log -5. They are both negatives. Okay, when you take log b of m, they cannot be negative. Okay, they cannot be negative. So this is a wrong solution. Okay, so we have two solutions, 5 and -2 for this quadratic equation, but we only have one answer, 5, for this log equation. So this slide has more detailed information about the checking step. You can read it in my PPT lecture file. For some other log equations, we have to use this property. Okay, this property. If you have same base b, okay, if you have same base b, so log b of m is equal to log b of n, well, implies the power m is equal to power n. Okay, so you can delete log and b, log and b. You get a new equation without log. Okay, so this is the one-to-one property. Okay, one-to-one property. Examples. I will explain the beginning steps of this example. For the quadratic equation part, you just look at the calculation here. Okay, yeah, the second part. So in the beginning, we have ln x minus 3 is ln 7x minus 23 minus ln x plus 1. So first, we combine these two log forms in the right hand side together. This is a subtraction, so we got the quotient. Ln x minus 3 is ln 7x minus 23 divided by x plus 1. Okay, so now by using the one-to-one property, we know we can drop this log form. We get a new equation without log. Okay, so it's x minus 3 is 7x minus 23 over x plus 1. Okay, so now we got this step in the slide. That's the log part. After that, you just change it, cancel the denominator, x plus 1, and then you get a new quadratic equation. Solve the quadratic equation, you got two solutions. Okay, you got two solutions. So x1 is 5, x2 is 4. And remember, you have to check them. Okay, you have to check them. So how you check them? You plug in 5 and 4 to these three parts to see whether they are positive. Okay, when x is 5, this is positive, 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 so 5 is okay. When x is 4, they're also positive, so we have two solutions. Okay, two solutions. So just make sure you take log of a positive number. So now let's add more examples. Okay, log 2 of x plus log 2 of x minus 7 is 3. So we put two logs together. We got the product. So now we have to use definition of log to change it to exponential form. X times x minus 7 is 2 cubed. Right? Read it counterclockwise. 2 to the third power is this product. X times x minus 7. So now we get a quadratic equation. X times x minus 7 is 8. Solve this quadratic equation. We got two solutions, right? X squared minus 7x minus 8 is 0. So x minus 8 times x plus 1 is 0. Two solutions. X is 8 or x is negative 1. Okay, so after you got these two solutions, you have to check it. Okay, check two solutions. When you plug in 8 and negative 1 to these two given logs, you have to make sure you are taking log of a positive number. So when x is 8, this is positive, so 8 is the right answer. When x is negative 1, log 2 of negative 1, so this is wrong. And the other one is also negative. So you have to drop this solution, negative 1. We only have one answer, x is 8. The last example. So ln x plus 2 minus ln 4x plus 3 is ln 1 over x. First, we use quotient rule to put these two lines on the left hand side together. Okay, so now ln means they have the same base e. So we can drop the log part if you have the same base. That's one-to-one property, right? So we get a new equation of two fractions. Okay, so now we solve this equation. Okay, we multiplied both sides by two denominators, x times 4x plus 3, x times 4x plus 3. So on the left hand side, these two canceled. On the right hand side, x canceled. Okay, so we have x times x plus 2 is 1 times 4x plus 3. Okay, so solve this quadratic equation. Solve this quadratic equation, you will get x is 3 and x1 is 3 and x2 is negative 1. Okay, so now we will check it. Okay, we will check these two numbers. Okay, check these two numbers. When x is 3, x plus 2 is positive, this is positive, this is positive. So they're all positive. Okay. When x is negative 1, okay, when x is negative 1, the first two logs are positive, but the last one on the right hand side, this one, you take ln of 1 over negative 1, so it's a negative number. You have to drop x2. Okay, so we only have one solution, positive 3.